All right, today I want to do some integrals involving trig functions. And the first two integrals I'm going to do involve the secant function. One of these integrals is really easy and is something you should know for the gateway exam. The other one actually looks easier, but is much, much harder, strangely enough. So the integral that's really easy is that one. And why is that easy? Somebody tell me the answer. Tangent. Plus c, don't forget your plus c. Okay, so that's a memorized integral. The integral of secant squared is tangent. That's something you should memorize because the derivative of tangent is secant squared. You know, if you didn't have that memorized, you'd look at that and you'd say, boy, that looks really hard. I have no idea what to do. But if you remember the derivative of tangent is secant squared, then it's easy. By the way, that's the same as 1 over cos squared x. So that would technically be an easy integral to do as well, though we don't write it that way in the gateway. The next integral looks a lot simpler, integrating secant of x to the first power, but it's actually a much, much harder integral. You could sit here for days on end trying to figure it out, and most likely you would not be successful unless you look it up. But it is possible. And to do it involves one of the strangest, most imaginative tricks that you've ever seen in a math class. Now, what am I talking about? There are standard kinds of tricks in math, like adding 0 in a convenient way. You know, maybe you add 5 and you subtract 5, for example, at the same time, because it might help you simplify something. Or multiplying by 1 in a convenient way. Maybe you multiply by 5 and also divide by 5 because it might help you simplify something. We're going to do that second trick. We're going to multiply by 1 in a convenient way, but the convenient way is completely unexpected here. It's the strangest form of the number 1 you've ever seen. It's secant x plus tangent x divided by secant x plus tangent x. Whoa, what in the world are we doing there? It seems like we made the integral a lot harder, but it actually makes it easier. If I just take this and distribute it through the top, something amazing happens. And David, do you want to say what that thing is?
Oh, I was going to point out that that is all, I think, well, I was going to point out that I got my
Okay, it's all right.
I thought it was confused secant x plus tangent x for secant x times.
Okay. Yeah, oftentimes with trig functions, identities are really useful, but here it's actually simpler even. I purposely switched around the functions on the bottom of the fraction to try to highlight something. Does anybody see what I'm trying to highlight? Go ahead.
Identities.
Well, be more specific. Here's a hint.
I was going to point out that, like, isn't secant x times tangent x equals something?
It's the derivative of secant. Anybody else see what I'm doing? Yeah, secant squared is the derivative of tangent. Secant tangent's the derivative of secant. The top is the derivative of the bottom. If I let w equal tangent of x plus secant of x, then dw will be secant squared x plus secant x tangent of x dx. Now, maybe you've forgotten the derivative of secant is secant times tangent, but that is true, strange as it may sound. This integral is nothing other than, after that substitution, the integral of 1 over w dw. An easy integral to do. Amazing. Isn't that astonishing? Whoever thought of that, they deserve a prize, $1,000 prize. That integral is the natural log, right? Well, technically of the absolute value of w, if we want to allow for the most general antiderivative, because w could be positive or negative. Tangent of x plus secant of x could be positive or negative. So I want to include the absolute value signs there. And now don't forget to substitute that in there. So the final answer is evidently natural log of the absolute value of this tangent of x plus secant of x plus c. Amazing. You never would have guessed the answer involves natural log, but it does. Okay, that's one of my favorite integrals to do. This one's, again, easy because it's memorized. This one is really hard. You would not have that on the gateway. Why is it worth doing? Well, partially because it's so amazing, and partially because it actually does come up in some applications. And I hope we have time to see that. But I won't rederive the integral next time. Pretty cool.